Hello everyone, I'm Said and welcome back. In this video, we're gonna learn about sigma notation, also called summation notation. Sigma notation is a short and convenient way to write the sum of many terms. Instead of writing every term separately, we use the Greek letter sigma. Sigma notation is especially useful in algebra, sequences and series, calculus, and Riemann sums. Now consider the following summation. We read this as the sum from I equals 1 to n of ai. In this notation, sigma is the summation symbol, I is called the index of summation, 1 is the lower limit, n is the upper limit, and ai is the general term. The index starts at I equals 1, then increases by 1 each time, and stops at I equals n. So the sum of ai from I equals 1 to n equals a1 when I equals 1, a2 when I equals 2, a3 when I equals 3, and an when I equals n. Right? For example, the sum of I from I equals 1 to 5 equals when I equals 1 is 1 plus when I equals 2 is 2, when I equals 3 is 3, plus when I equals 4 we write 4, and when I equals 5 we write 5. So we have 15. So the sum of I from I equals 1 to 5 is 15. Now let us expand a few examples. The sum of k squared from k equals 1 to 4. In this problem, the index k takes the values 1, 2, 3, and 4. So we have when k equals 1, we have 1 squared, plus when k equals 2 is 2 squared, when k equals 3 is 3 squared, plus when k equals 4 is 4 squared. So we have 1 plus 2 squared is 4, 3 squared is 9, 4 squared is 16. So we have 30. So the sum of k squared from k equals 1 to 4 is 30. Right? For example, expand and evaluate the sum of j plus 1 from j equals 2 to 6. The index j starts at 2 and ends at 6. So we have when j equals 2, we have 2 plus 1, plus when j equals 3 is, we have 3 plus 1, plus 4 plus 1, plus 5 plus 1, plus when j equals 6, we have 6 plus 1, right? So we have 2 plus 1 is 3, plus 3 plus 1 is 4, 4 plus 1 is 5, 5 plus 1 is 6, and 6 plus 1 is 7. So we have 25. So the sum of j plus 1 from j equals 2 to 6 is 25. We expand the sum of 2 to the power of r from r equals 0 to 3. The values of r are 0, 1, 2, and 3. So we have when r equals 0, we have 2 to the power of 0, plus when r equals 1, we have 2 to the power of 1. When r equals 2, we have 2 squared, plus when r equals 3, we have 2 cubed, right? So we have 2 to the power of 0 is 1, plus 2, plus 4, plus 9. So we have 15. So the sum of 2 to the power of r from r equals 0 to 3 equals 15. Now we're gonna find the number of terms. To find the number of terms in a summation, we use n means the number of terms equals upper limit minus lower limit, means for example 3 plus 1. So in this problem, the number of terms equals upper limit is 10 minus lower limit is 3 plus 1 equals 8, right? So the terms are 3, 4, 5, 6, 7, 8, 9, and 10. There are 8 terms. Or for example, in this problem, how many terms are in the following summation? Using the formula means n equals upper limit means 20 minus lower limit means 5 plus 1 is 16 terms. Notice that the expression I squared does not affect the number of terms. The limits determine the number of terms, right? Sigma notation has several important properties. Property 1, the sum of two expressions. For any expression ai plus bi, we have the sum of ai plus bi from I equals m to n equals the sum of ai from a equals m to n plus the sum of bi from I equals m to n. This means that we can separate the summation of sum into two separate summations. For example, evaluate the sum of I plus I squared from I equals 1 to 4. Using the property, we have the sum of I equals 1 to 4 I squared plus the sum of I from I equals 1 to 4. Now evaluate each summation. First, the sum of I from I equals 1 to 4 equals, when I equals 1 we write 1 plus, when I equals 2 we write 2 plus 3 plus 4 equals 10, right? And the sum of I squared from I equals 1 to 4 equals, when I equals 1 we have 1 squared plus 2 squared when I equals 2, when I equals 3, when I equals 4. So we have 1 plus 4 plus 9 plus 16 equals 30. So we have the sum of I squared plus I from I equals 1 to 4, we have 10 plus 30 equals 40. The difference of two expressions. Similarly, the sum of ai minus bi from I equals m to n equals the sum of ai from I equals m to n minus the sum of bi from I equals m to n. For example, the sum of I minus I squared from I equals 1 to 5. We have the sum of I from I equals 1 to 5 minus the sum of I squared from I equals 1 to 5. And we know that the sum of I from I equals 1 to 5 equals 1 plus 2 plus 3 plus 4 plus 5. We have 15. And the sum of I equals 1 to 5 I squared equals 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. So we have 1 squared is 1 plus 2 squared plus 3 squared plus 4 squared plus 5 squared equals 55. So final answer is the sum of I minus I squared from I equals 1 to 5 equals the sum of I equals 15. So we have 15 minus 55 equals negative 40. If c is a constant, so we have the sum of c times ai from I equals m to n equals c times the sum of ai from I equals m to n. This means that a constant can be taken outside the summation. For example, evaluate the sum of 3i from I equals 1 to 6. Since 3 is a constant, we can write 3 times the sum of I equals 1 to 6 I. So we have 3 times the sum of I from I equals 1 to 6 equals 1 plus 2 plus 3 plus 4 plus 5 plus 6. So we have 3 times 21, so we have 63. So the sum of 3i from I equals 1 to 6 is 63. That's it for this video. In the next video, we will learn some more properties of sigma notation, and then we will solve a few examples together. Thank you for watching and see you in the next video.